Hi everyone, David Maley here, and today I'm going to show you how to do some really exciting stuff. It's forecasting in Excel. And with forecasting, I can actually predict the future with a high level of confidence. And there's a couple of different ways to do it. We can do it with time series, or we can do it with other variables like temperature. In this case, we're going to use both, and I'll show you that temperature is better in this case. But it depends on what you're doing, and if you want a linear trend or, you know, kind of how accurate you want to be and how the numbers you want them to look. So what we're going to do is we're going to start off getting the forecast. I'm going to create some fields in here. I'll show you what I've created, and then I'll show you how to graph it and how to show exactly the upper bounds, lower bounds, and the trending. So this data set we have right here is from the University of California, Irvine's Data Science Department. It's public. You can go and download it yourself. It's the bike share data for 2 years worth of bike share or bike rentals, 2011 and 2012. So this data set here I've shown in the previous video that I went and created a running total. You can watch another video I have out there. The predecessor to this shows you how to make the running totals, and it shows you how to make a conditional running total, which is what this one is. We're not going to use those two today, so I'm just leaving them in there. So what I've done here, I want to show you is I've converted, there's a temperature field back here called temp, and there's a temp. Okay, and I've taken this, it's a percentage or a decimal, I'm sorry, and I've multiplied it by 100. Very simple to do here. So it's, looks like regular degrees, 34 degrees, 19 degrees, 20 degrees, and then of course during the summer it goes up to 70 degrees and so on. You can see here. And then you double click on the right part of it, you go like this, and double click on when it gets to like that, and then you can carry it on down. But what I've done next to it, I want you to see here, is I have created a couple new columns. Okay, forecast casual temp, time series, regular users. So you have casual users. If I go back here and show you their data, you have casual users, which are people that are new users. You have registered or subscribers, which are returning users, and then you have CNT, which is your total count. That would be your total rentals for each day. This goes by day on down. And if you look over here, I have upper bound and lower bound too. So now what I want to do is I'm going to go all the way down this, and I want to see out of all of these fields I have here, which ones have correlations in them, because they would be optimal to use. You don't want to use something that has a low correlation. So what I did was I used a formula, which is right here. I'll show you right here. CORREL, CORREL, and all you got to do is type it in, and it'll pull up the rest for it. And what it does is it's going to give me a correlation between two bounds. So if you look here, I have P2 to P732, so that's for count, and 732 is the last one I have for it right there. And all I did was I freeze framed these so that again, if you want to see that, all you got to do is click View and hit Freeze the columns or the rows. In this case, the rows, and that way I can see the top row as I look at it. Anyway, so by using CORREL here like this, so I'm using the P as the count, and U is right here. That's the temp 100 field that I showed you, that I just created, and I'm comparing the two. I want to see the correlations between the count, the total number of rentals, and the temperature, and to see if there is a correlation, and there is. So the closer you are to 1, obviously the better the correlation is. In this case I have 0.627, basically 0.63, which is pretty good to use. And then I also did it just to show you with registered users and casual users, and you actually see the registered and casual users are a little bit lower, but when they're combined into the count, it's actually higher, the correlation with temperature. So we're going to use that, but let me show you what I did here. So over here, if you see at the end of the last row for the data set's 732, what I did was I put new dates. So I've got, it ends on 12/31/2012, and it shows all the dates through 2012. I've now added 2013 in the first 15 days of it. Okay, and so if I go over here, I want to show you that what I've done is the month obviously becomes 1. Okay, and here's how the month is calculated. It's the month formula and times the B734. So you have to go back to B, and that would be the date. So it takes for that month the date, it gives you the date, or I mean the month number, and then I've also got the year formula here that gives you the year. And then the temperature, these would be temperatures unlike these guys up above that are given to you in the data set. This would be depending on what the temperature is. So you can go and look at online and get what the temperature should be on those days or what it's projected to be. And then you can use that to draw your forecasts from. So what I want you to see, one thing here before we get too far into the forecast, is let's go over to dates. Now I want you to see something important here is I've got two 12/31s, two December 31st, and there's a reason for that. Because if I don't have that there, what you'll see here is that I have a temperature of or the temperature here is 25.2 here, it's 21.6 here. What'll happen is you'll have a point, when I graph this, that they won't meet. They won't look right. It won't look good. So we want to be clean. We want the forecast to come straight out of our previous numbers. So what I do to do that is we create another 12/31 date without any info in it, right below the other one, and it goes just like this, 21.6. Okay, it's the same date, but what you'll see here is the forecast count, okay, right here, is going to be the exact same as the count right here. And that's so that way the forecast, once the forecast starts going up or down or whatever, it bounds straight into the last number from the last item in the data set. That's important to have. And then the upper bounds and lower bounds, all they are, in this case, in the first one, it's going to be the same because you want them to pull off that. And I'll show you in a minute when I have the graph. Well, actually, let me show you right now. So in the end, I'm going to create this graph. I'm going to show you how I do this. I've got a pivot chart here. But look what happens. See, because I have that date in there of 12/31/2012 with 27/29, everything goes to that same point in here. And then it expands out. Okay? That's what you want to see in a forecast. So if I go back here, you'll see then, after that, I'm going to start pulling in forecasting info. Now, for the forecasts, I've got a couple different things here. I don't want to get lost in this. But what I've got is the first one's a time series. Okay, now the time series utilizes this formula right here, and what it's using is the time. So look at B734, or a date series. B734, let's go all the way across to see it, is this date right here, and it starts and goes this way. And when you use a time series, it's a trend line, right? So the trend line is just going to give you a line, and that's fine, but it's not what I really want to see, because a trend line is just a line. I can draw that myself. That's not very accurate. I want something much more accurate. So what I'm using here to the right of this, and this just carried that formula on down, okay, where I have the time, and then you'll see N2. So N, if you go back this way, is casual. So in this case, we're doing a casual versus registered versus count, okay? And the trend line just shows that building it, it's not going to be accurate, that line, at all. So if you look next to it, I've got forecast casual, but instead of a time series, I've got it based on temperature. So it's not much of a difference in the formula, but the difference is instead of having B734 at the start, which is the date, instead I have U734, which is the temperature. And it's the temperature of the forecasted temperature for that date, because that date will be in the future. Now obviously I'm looking at dates from 2013 so I can find them, but you can go and do this for any time series you want or any variable you want. And so you can clearly see here that when you put the temperature in here, then it goes again the same idea. So you got N2 to N732, or 732, which is the casual range for the data set that's given, and then you've got the temperature range for it. So what it does is it's going to base from these two the forecast, and here it is. So the forecast based on the casual numbers, so that's the new renters, or new shares, bike rental people. And look at the numbers. They go up and they go down based on the temperature because the temperatures fluctuate. It's not going to be in a straight line. So this is not as accurate. This is much more accurate and much more believable and better looking when you show it to your executives. Hey, here's the forecast for next month. Here's the forecast for next week. You can do this with anything. Temperature tends to be used a lot in many businesses because you can, their sales could be prone to temperature fluctuations. And you can utilize, your past year or 2 years or 3 years or 5 years of temperature histories in your data set and get a great valuation based on that. Now, so that's what I did for this one. The next one, what I did was the same thing, but I did it with the regular or the subscribers, right? So we have, if we go back here, we have a much larger number of subscribers than we do of new people. So the registered are right here, and I'm showing the wrong column, but here it is. Registered is O, and casual is N. So let's go back here and see how I have. So I've got the temperature, then I've got the range of the entire group of the data set for the registered users, which is over and O, and then I'm still using the temperature here. So in utilizing that, I come up with this. And then I can double click this and bring this value on down, which I've done. And then next to that I also have the forecast for the count. So the count, I can either do the same thing or I just have to take this and I get this by adding them together. Okay, and then I can carry that on down. And so that's what I really want is the forecast for the total rentals per day, okay, going forward based on temperature. And then next is what I want to see, as you saw in that graph, is the deviation. So it's kind of like how far from the mean are my numbers going to deviate. Now you also have an option in Excel where you can go into data and data analysis and you can pull this data based on your data set. I'm not going to go in that today. I'll go in that another day in another video. But what it shows you is your average, your mean for your data, and this would be for the new users. This is not for the total count. And this would be your confidence level. So what you get from this is you take this number, your mean, and you add your confidence level to get the upper bound, and you subtract it to get the lower bound. Now what I'm doing in here, just to show you, is same thing, upper bound, lower bound, but what I've done is I've taken Y, which is this column right in front of it, the actual forecast for the count, and I've multiplied it by 1.05, or that's 1 plus 0.05%, and then I've also multiplied it by 0.95, so that gives you the upper and the lower bound. But I don't want it to say 5% the whole way, because then it looks like it's the same throughout, and it's not. So what you want to do is you want to add a fluctuation, which is an increasing by 1% per day increase, and that's because as you go on in your forecast, things will be more volatile. There's more movement, so you want to be accurate. And so with a 95% confidence interval to begin with, we end up at the end, using numbers like 0.19% swing, okay, either way, of the upper and the lower bound. So what happens is then I carry this down, and you can see it's 1.09, 1.13, all the way to 1.19, and the same thing here in the other direction, because that's the lower bound. Then what I do is I go over here, and before we get to this graph, let's move this graph off here a little bit. What I want to show you is this right here. This is a pivot table that I've created, and the pivot table is based on all the data in the this data set that I have, plus the fields that I've added. So you can see the fields I've added do not have data for the data set, only to what I've added down below. And then these guys are off of the data set. Okay, that's your correlations and stuff. I just want to show you to see why, if it was useful to use temperature before I go and spend all that time creating all these forecast formulas. It's easy to just put the correlate formula in here and see quickly, is it above 0.5, how close is it to 1, and that's good enough right there, and you'll see there's a correlation with that. So what we do, and you can use other programs to do that too, is I have other videos that use Rattle and R to get correlation statistics. and which could show you a little bit more of, is it 0.89, is it 0.6, and what other items in here, what other fields are more closely related. But this is good enough right now. I know that temperature is going to be solid for using forecasting in this, because think about it, it's bike rentals, right? Who's going to rent a bike in the winter versus the summer? You're going to have a lot more in the summer. On a really hot day, people aren't going to rent as much. On a wet day, they're not going to rent as much. So we can figure out some of these things from weather, predictions and stuff we can get from the internet and from different news sources and stuff like that. So now that we've done that, what we want to do is we want to make a pivot chart. So if you don't know how to make a pivot chart, you just go to Insert, you click on Insert, you click on Pivot Table, you put it where you want it, then you right click on the data, that you want to use. You select the data, which we'd go back here and we'd select all the columns that we want, hit enter, and it'll, then we get to choose what columns we want. So, I've chosen here that I want to have the dates, I want to have the count, this and the sum of the forecast count. Everything I want it to be a sum. I don't want it to be a count. So I want the sum of that. If I have the count, it's not going to give me the true number. So I have sum of forecast count, sum of upper bound, sum of lower bound, sum of the forecast, and sum of the count of the original CNT field, which is the total rentals or shares for the day. And that goes in there, and you can see it's got both that and the lower. I don't really need the grand total. I don't use it here. You can always right click on that and remove the grand total if you don't want it. I don't really care. It's not affecting anything in my graph. So let's go to the graph, and you can also remove blanks. You don't want to have a blank out there. By putting that in here, what you can see here is I have the sum of the count is right here. But you see I picked 4 fields. So sum of the count is right here. I also picked sum of forecast, sum of upper bound, and sum of lower bound. And if you look here, automatically Excel is going to give you different colors for each of these items. The sum of the count ends here. And now you can clearly see why I wanted to use that date twice. So I can set it as an endpoint and an entry point. For the endpoint for the count, which is this area to the left, and an entry point to the forecast, so they all meet at the same point. I could zero in on this, make this graph as big as I want, and you'll see that this flows nicely into this. If I didn't do that, it would jump. It would go from this to boing a different spot, and there'd be a space in between, and it wouldn't look professional or proper. So by doing what I showed you in the first thing right here, by doing this little doubling of this row, where we have the first one for the same day has it as 22.9 or 27.29, I'm sorry, for the count, and then the other one has 27.29 as the count in the forecast count. See that? With the temperature being the same, that makes so that both lines meet. Okay, so next we go back here, and you'll see I've removed any of the labels here other than the legend, and you have sum of forecast count is in red, so that's your actual forecast count, right, is the red. Now remember, we did the upper bound, the lower bound. By doing it, if we just left it at 5%, it would have this line would be the same distance here as it is at the end, which would not be accurate. You want it, as your forecast goes out, to be narrow at the beginning, which is more accurate here, and obviously less accurate here, so it's got to be wider and show a bigger percentage of variability. So by adding 1% per day, you could do 1% every 2 days. I could have done this over 2 days instead of single days. I decided to do it over single days, but you could do it however you want. What you can see here is it starts off at 5%, and then it ends up at I think it was like 19% plus or minus. So that's how we did that. And if you look at this, this gives them, it's a great looking graph that shows, hey, here's what our sales were up to this point. We don't have the data beyond this. We're forecasting now. I know this is 2012 and it's actually now 2018, so this is old data, but the premise is still the same. So this could be 2018 data. This would be later 2018 or 2019 data, and you're actually predicting the future. based on temperature, which is really cool because a lot of companies are doing this. A lot of sales departments are doing this to project their sales because temperature in many cases could be, if you have the correlations there, related directly to your sales. So by using that, as I did here, instead of doing a time series, so if I use the time series one, you would just have a straight line going bzz, and that would look really dumb. So this is much more accurate looking, and it shows based on the, if the temperature is higher, obviously it's going to be in the higher end of that. But you can see these bands. So like investing, they use Bollinger Bands and different bands, and you can have a high prediction that, okay, it may not be on the red mark here on, what would that be, around 110, 109, but it's going to be most likely between, and there's a 95% confidence or higher that it's going to be between the green and the blue. So we can pretty much project that in this range, that's where our sales, or in this case for this data, our bike rental numbers, total count is going to be. And I could have projected this based on just the new customers, the casuals. I could have done it based on the returning subscribers. I could do it on both and then just figure out, okay, well, maybe we need to work on our subscribers and getting new customers to be subscribers and do some marketing there, do some additional discounts or loyalty program type events to get people from being a new user and get them to buy like maybe a series or a book of bike rental coupons so that they return more and become a subscriber. And in the industry, this is used a lot, and the reason being is loyal subscribers are worth a lot to any business. So, or loyal customers, whatever you want to call them. Loyal return customers, subscribers, registered users, they're worth a lot. So you want to keep them, and you want to see where they are. But in this case, I'm just looking at the projection of total rentals. And you can see it here. So again, that's how I did this. The data from the data set ends here at 732, column 732, and then I've added everything down below. So I doubled up 1231 so that they match. If I took this one out, you would see a jagged area where it's not really touching correctly. You want to avoid that. When you give data to people, especially as an analyst, a data analyst, you want it to look clean and sharp. You don't want to say, hey, what happened here? There's like, these aren't matching, these aren't correct. There's a space here. What is that? You avoid that by putting this data in here and listing the registered number right here, and then the same, or I mean not the register, I'm sorry, the count, which is 2729, and doing it again right here. And then see what I've done is on that first day, I don't want there to be, an upper and lower bound, so because it would throw it off. So I want them to come out of that date. So notice how I have them all equal on just that one day that I have it back there, and then I have the 3 right here as both the count, the upper bound, lower bound, they're all equal. Then the next day, where the forecasting starts, 1/1, you'll see that I have an upper bound and lower bound starting based at 5%. So to get that, it's times itself, 0.05 for the upper bound, and again the lower bound. So let me show you again here quickly so we can review here the formulas I used. Obviously, the temp 100 is not a big deal. All I did was take the temp, which was given to us in the data set as like 0.36 or 0.70, and I multiply it by 100 so that it's in normal digits for us. So we can say, oh, it's 29 degrees, it's 30 degrees, it's 30.2 degrees, it's whatever. So it looks normal. Other than that, we have the first formulas I used here and showed you is correlations. I could have picked wind speed, humidity, anything I wanted to in there, or a combination of them, and tested the correlation of them. So what I did here is I used the CORREL, which is for correlation, this formula. And again, P is the count, and U is the temperature that I brought in, temp 100. And I went and did that just for, as you can see here, the ranges of the data set that I was provided, or that I found. You can use this for any data set you want. And I did that also for the registered and the casual, just to see if one was better than the other. Combination is better than the other two, so I stuck with that one. Then I come over here, and the first forecast formula that I started with was actually a time series. And the time series, I just want to show you the difference between a time series and using a variable like temperature. So the time series just draws a line. If you see it's 1175, 6, 77, 78, 79, it goes up basically by 1 and just keeps going. So it's a straight line. I didn't want to use that. It's like a trend line. It's not very accurate, and it's not very showy, and it's not something you want to show executives unless they decide they want a trend line. Sometimes they do. That's fine. If you want that, this is the formula for creating a time series trend line quickly in Excel. Next to it, all I did was see the difference. It's almost the same formula. That's why I wanted to show you that. But instead of using the date, B734 is the first date, 1-3. Instead of using the date, now we're using U734, which is the new temperature, and it would be a forecast temperature. It would be like going online to weather.com and going getting, okay, what's the next 2 weeks weather? And here it is. Boom, 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 boom. You fill that in, and based on the forecasted temperatures, which is usually pretty good. I mean, they may be off by some, by 5 degrees, whatever, and then that's why we have the upper and the lower bounds. Okay, so you have the time series, you have the based on temperature. Again, you've got, you pick your temperature, and which is this one, and then you have your ranges. So you have your range of your N, which is your casual in this case, and your temperature. Then from your original data set. Then next to it I have for the registered users the same thing. The only difference is we use the O column for registered users. And then the next one is the count. I could have used the column next to O, which is P, which is your count, but being that I already did casual and registered, all I have to do is just add them up. It's the same thing. So I went and you can run these down. Once you've done it, you go here to the right corner, double click, and it runs it down to the end of your numbers here. And then we have the upper bound that we calculated. So we take this number times 1.05 for the upper bound and times 0.95, which is minus 5%, for the or 95% of the total for the lower bound. And then I don't carry that straight down because that would be straight lines that wouldn't vary more as it goes along, which it really needs to. So what I did was I added an extra 1% per day, and then for the upper bound, and I subtracted, took away an extra 1% per day for the lower bound, all the way down till it's basically 90% one way or the other. And then I took this whole thing, made a pivot chart, okay, which is right here, and from that pivot chart, then I just hit insert chart, and I picked a line chart, and I picked out of that pivot chart the count, forecast count, upper bound, and lower bound. And then with that, what happens is it just goes straight in here with a line graph, just like this. And because we built the data correctly, we have that row of 2 dates for the same, or 2 days of the same day for 12/31. They combine exactly correctly here. So even if I took this and I wanted to make this bigger, oops, dang it. Let's take this and make this bigger. There we go. See, if I make it even bigger, see how it looks nice? It goes straight from the count, boom, there's the red, the green, and the purplish line comes straight off of that. And you can see at the first instance, there's 5%, but it grows. So see how the spacing grows over time? That's to show you the level of error is going to be higher over here, but it still contains in that area. So I know with a 95% or a very high level of confidence that, where my sales are going to be on each of these days going forward. Now, and keep in mind, again, this is from 2013-2012's data, but you can do this for any data. You just have to go and follow these, this idea, make sure it's correlated. If it's not correlated, you're going to be giving people data that's not very accurate. And so you want to make sure you utilize that first, make sure it's correlated. So that's back to over here, this formula. Then you go and do your forecasting, figure out if you want to use a time series or not. You probably won't, but you may, you never know. And there's other ways of doing forecasting too. This is just a very simple method to do it in Excel and to give good, clean results, quick and fast, that are very impressive and look really good. I hope you found this helpful. Got a lot of other great videos coming on. I'm going to do different ways of forecasting, different ways of determining various formulas and wrangling your data and getting your data to where you can go and manage it and better see insights and better give insights to your customers and better give them information and graphs and show them exactly this is why the data is doing this. This is why sales are here. This is why the market's not doing well. This is why this product's not doing well. Or this is why this product or this event or this campaign is doing great. That's what the data, this can make forecasting is exciting because you can say, okay, here's my sales and here's where they're going. And this is why. And this is, this is very good. And it gives executives a way to say, okay, we can plan our levels of these different products for this level of sales. And they should be very close to where they want to be. That's what forecasting is all about. Getting the right product to the right people at the right time, at the right price, and making so you're not overstocked, so you don't have shrinkage or loss or unavailable items for customers. That's the worst thing. You never want to turn away customers because you don't have a product because you didn't do the calculations and analysis correctly beforehand. This is never going to be 100% accurate, but it gives you a very good idea of where you are, where you're going to be, and in this case, for this data set, where your bike rentals are going to be for the next 15 days or so. And I could carry this on as long as I wanted to, as long as I had available forecasted temperatures using it in this manner. I hope you found this helpful. Thanks for watching. Please take a moment to subscribe and like, and have a great day. Thank you.